This is the second lecture on holding other factors constant. So the first one dealt with what exactly it means. This one deals with, well, what should you hold constant? Just because you can hold something constant doesn't mean that you should hold something constant. And so there are four different main objectives of regression analysis. This is in section 2.2. We'll talk about it in a future lecture in a little more detail. But this little video deals with what you should hold constant when you're estimating causal effects. Okay, causal effects deals with policy issues. It's the most common use of regression analysis. Okay, so I'd like to share with you this video. This is called a kinetic ball sculpture. And it's something that my wife and I ran into in the Vancouver airport as we were going from one plane to the next plane. We saw this thing. We just got mesmerized by the sounds and the visuals with it. And so let me play about 20-30 seconds for you. And there is a point to all this, which you'll see in a moment. So as we were watching it, the perhaps geekier side of us, we're trying to figure out how many different pathways can the ball go. And it wasn't too hard. Eventually, we figured out that there were 4 different pathways. And then a couple weeks later, here I was teaching about holding other factors constant, and my mind came back to this. And so I thought, well, what would happen if we held things constant? Okay, so there are 4 different pathways, and if my wife and I had the time between our flights, we could actually stay there and calculate the probabilities for each of the different pathways. I'm guessing it would be roughly equal. But what would happen if we held something constant? I mean, let's take this node right here, or the pendulum node, and let's say that it was the pendulum was leaning to the right, meaning that every single time the ball came that way, the ball would go to the left. Well, then we wouldn't get the same probabilities for the different pathways as we would if we did not hold that constant, if we did not fix that. Okay, and this is basically what happens when you hold something constant, that after there's the initial treatment, well, here the treatment would be the ball gets released. Well, then you're not seeing the full effects of what happens. Okay, I'll come back to this in a little bit. Okay, let's use as an example the research issue of how kids' TV watching affects their weight. And so we would be interested in how, let's say, their average daily TV watching, you can measure it in hours, affects their body mass index, BMI, which is a measure of how much a person weighs divided by their height. Usually it's age and gender adjusted for children. Okay, so when I create a model like this, we want to think of the arrows and the value of the arrows. So in this case, I'm calling it A, is going to be the true causal effect of a 1-unit change in the pointing variable, meaning the 1-unit change or a 1-hour change in TV watching on the pointed to variable, in this case, body mass index. Okay, so the regression model should look something like this, that we're regressing the outcome, BMI, on TV watching, and then some other set of X variables, some set of control variables that we think would be appropriate and help us try to estimate this true effect, a true effect that we actually don't know what it really is. Okay, so A is the true effect. We want our estimate of beta 1 to be unbiased, as close as possible to A. And so we need to think about, what should we control for? What variables should we put in X to try to get beta, our estimate for beta 1 to be as close as possible to the true effect of A? And so here I give 3 options for X. First of all, whether a child lives in a single parent household, we'll call that variable SP for single parent. How much exercise does the child get? We'll call that E. And how much junk food does the child eat? Call it JF for junk food. Okay, so now let's consider whether within that the set of X variables we should include that variable for whether the child lives with a single parent. Okay, now I am not going to make any assumptions on it, but we have to entertain the possibility that a child living in a single parent household, well, that could affect how much TV they watch. Perhaps the single parent has a harder time monitoring the child and so wants something easy to keep track of the child, just to have him or her watch TV. And it also could be that having a single parent could affect body mass index, maybe from lower income, maybe just from not having enough time to prepare healthy meals as would a two-parent household. Again, I'm not saying that that is necessarily the case, but it's a possibility. Okay, so the question is, should single parent be a control variable? And here's the question. As the amount of TV hours varies in the sample among the different children in the sample, do we also want being a single parent to vary as well? Okay, now this goes back to our chocolate chip cookie example. As we vary whether or not there's cinnamon in the two batches, do we also want anything else to possibly change, such as chocolate, sugar, or butter? And so the answer was no. We wanted the difference in taste between the cinnamon and non-cinnamon batch just be due to the cinnamon and not due to any differences in chocolate, sugar, or butter. Now in this case, we want any differences in body mass index for people of different or kids of different levels of TV watching to just be due to the differences in TV watching, not to differences in whether the child lives in a single parent household. Okay, so this is a case where we would want to control for the single parent to avoid omitted variables bias. That is, we want to make sure that living in a single parent household is not a confounding factor, or that the estimated effect of TV watching is not picking up the effect of living in a single parent household. Now we will consider two more possible control variables: the amount of exercise the child gets and how much junk food the child gets. Okay, so I moved down A there in that arrow because I'm going to fit in here three different mechanisms for why average TV watching affects body mass index. Okay, so the first one is that TV watching affects how much exercise a child gets, and that in turn affects their body mass index. TV watching could affect how much junk food a kid eats, and again, that could affect their body mass index. Those would be mechanisms 1 and mechanism 2. And TV watching could affect just other factors, other things, which I can't think of right now, and that could affect body mass index. I'll call that mechanism M3. Okay, now I have some overlap here between the mechanisms, and the point of that is that, well, some of these are interrelated. Okay, so to decide whether we control for exercise and junk food, we have to ask the question, as the amount of TV varies in the sample, as we see some kids watching a lot of TV, other kids watching little TV, do we also want the amount of exercise and junk food to vary with it? Okay? So what happens if we control for exercise and junk food? What that means is that as TV varies in the sample, then the amount of exercise and junk food do not change. They're not going to vary. They can't, because they're being held constant. That's what holding other factors constant means. Okay, and so what happens then is that we lose those two arrows from TV watching to exercise and junk food. If we lose those arrows, then, well, guess what happens to M1 and M2? We lose those as well. And so now our estimate for beta 1 is no longer capturing mechanisms M1 and M2. In fact, we're even probably losing part of M3 to the extent that it might be correlated with M1 and M2. So that is, our estimate for beta 1 is only capturing the effect of TV watching on body mass index through mediating factors other than exercise and junk food. Okay, so we're no longer getting the full effect of TV on BMI. And what we're left with is really something that doesn't have much value or doesn't have much meaning. We don't know, hey, if we put our children in front of the TV, how is that going to affect their weight? We have no idea if we estimate this model. Okay, so the lesson from this, unlike with the other case where we wanted to control for whether the child lived in a single parent household, here we don't want to control for the amount of exercise the child gets or the amount of junk food the child eats, because then we're taking away from the full effect. We're only estimating part of the full effect of TV hours on BMI. Okay, so I want you to take a minute or so and think about, what do you notice here? Okay, in the case of single parent, yeah, we want to control for it. In the case of exercise and junk food, we said, well, no, it probably is not a good idea to control for it. So what characterizes each set of variables? And then think about how this relates to the kinetic ball sculpture. I'll let you think about that for a moment. You can pause the video. Talked about how my wife and I were trying to figure out, okay, how many different pathways are there for the ball? And then one could calculate, well, what is the probability of each pathway? Okay, but if we held something constant, let's say we held this node constant, so that it's when the ball comes this way, it always goes to the left. Well, now we're no longer getting the true probabilities. And so basically, the ideal thing to do here is let the ball go from up here and let things play out. Let everything happen. Don't control for what happens after you release the ball. Okay, likewise, in this case, once you see kids having different amount of TV watching, let it play out. See what happens afterwards. All the things that occur afterwards, the amount of exercise they have, the amount of junk food they eat, and then that in turn is going to allow body mass index to change, the true effect of TV watching on BMI.